everyone, we're ready to get started. So today for our agenda for this webinar is we're going to start out just with the, I'm just going to go through the housekeeping rules for the webinar. I'll give you a company profile on Larson Software. Then we'll have an introduction. We'll go through the history of illustrations, the present and the future overview. And we're going to cover some of the 2D and 3D graphics technology that we think apply to this. Some of the ones that we're showing there on the screen, like X3D, SVG, CGM, and then we'll cover, give you an overview of the relevant technologies, and then a summary, and then we'll wrap up with a question and answer session. The housekeeping rules today: if you have any problems and need to communicate, use the little chat window to communicate. All attendees will be muted for the duration of the webinar. Computer audio is a recommended option, but there also is a call-in number, which was listed on our front page. The associated materials are available in handouts over the little control panel. There's a little handouts box. You can drag and drop those PDFs to your desktop, and we invite you to do that. Post your questions at any time during the webinar, but we will answer them at the end. But as you think of them during the webinar, feel free to post them. That'll help us, give us time to think about them too. Have some good answers. So Larson Software Technology is based in Houston, Texas. We were founded in 1984 and are graphics technology experts for over 30 years. We develop innovative graphic software and toolkits, both end user and toolkits based on open standards like CGM and SVG. We promote CGM usage by providing a free CGM viewer, which has now been replaced by a subscription version, which is available online on our web store. We're the first developer of an HTML5 CGM viewer to eliminate the need for plugins for viewing CGMs in browsers. We're a member of the CGM Open Foundation. Larson's technology simplifies the graphics workflow for tech pubs, professionals, engineers, and geologists and geophysicists. And those are our websites there. So with that brief overview, I'm going to turn it over to David Manick for the body of our webinar presentation.
Thank you, Don, and good morning to everybody, or good evening, good afternoon, wherever you may be. Yeah, so thanks for that, Don. I think a good introduction to the webinar today, and this is a topic certainly close to my kind of heart, being an illustrator back in the old days, and we'll kind of touch on that today as well. So I wanted to just really discuss a bit about the history, only for a small time, really just give some context to the presentation. So, and also we're obviously going to look at what we feel the future is for technical illustration for a creation and delivery perspective. So the facts, certainly there's a vast amount of 2D legacy data. So we don't really see that going away very soon, or if at all. So that has to be continued to be used and revised in the future. So we're still going to need 2D software to do that in an efficient way. So, and that's something we'll also discuss today. Today, most of the new illustrations, I would say, are created from 3D CAD data, but they're still converted to 2D. But I think the use and delivery of 3D data will become more common in the future. And that will obviously be driven by cost and of both software and hardware. And I think we'll also see the use of AR, augmented reality, as well. I think we're already seeing that in some applications, but that would predominantly be in the maintenance area. So if you're repairing uh, or assembling something, then that's going to be really useful to help you. Already in the training area, 3D is used a lot for kind of initial training of maintainers and so forth. So we're going to focus on 2D and 3D data delivery during this webinar today. So if we're looking at the history, well, I think we all agree, certainly with our illustrators, that pictures are a really useful way of communicating information. So even if we go back in time, you know, we had cave paintings, which could not only be decorative, but they also could have been instructional in nature. And certainly hieroglyphics were like an early form of pictorial communication. But one of the people I feel was one of the first technical illustrators or communicators was Da Vinci, who was also an inventor. Probably some of you know this, and he illustrated a lot of his machinery and even created exploded views of it. So there's a long history here of illustrations providing information to people to either assemble, repair, or maintain machinery. But if we go back, certainly when I started, a lot of illustrations were created on the drawing board, and these were usually done, it was more like art, to be honest. We had like 3-point perspective pencil illustrations created from flat engineering drawings, and the illustration was then traced and inked onto translucent film, and in the end artwork was created by photography, like large format cameras to photograph that artwork to insert into the master publication. The first major change I see was desktop publishing. So we saw the advent of things like PageMaker and also Adobe Illustrator and Corel Draw in those early days. I don't think illustrations really at that point, or certainly 3D type illustrations, were done at that time because usually the technology just wasn't there. So from a software point of view. But that changed with the introduction of specialized software for technical illustration. But invariably, that was really very expensive in the beginning, and it was mainly on Unix workstations. I think Tito Isodraw was a real game changer, though, in this, available on Apple Macintosh. Although the price point was still, for some, too high, it really gave an easy-to-use illustration tool, which was much more affordable. A friend of mine has kindly donated for the webinar today some illustrations. So if people are not that aware of going back what illustrations look like, because today we don't really see this type of illustration too much, because the racing car we see here was like completely 3-point perspective. It had ghosting effect, so it would have taken a long time to create this. And perhaps we've moved away from that nowadays. And then we have a more traditional illustration, again still with perspective, but this time with the thick and thin line technique, which gives it that depth. So even though it's 2D, it kind of gives you the impression of 3D illustration. And then I really like this example because it shows color, because illustrators did color illustrations with an airbrush, or now more likely in Photoshop, which shows how you could actually have something that you couldn't achieve with a photograph. You could have a line illustration at the rear and the full color at the front. So I'd just like to thank Roy for providing those today. There's lots more examples on his website if you want to go and have a look. So today we really see illustrations really completely being created electronically or revised or edited electronically. But they're still, I would say, primarily black and white, and usually a simplified perspective projection like isometric or parallel perspective. You could see the thick and thin line technique I mentioned earlier. You can see it there on the right, which adds some quality to the illustration and some depth to it, but sometimes it might get sacrificed because of cost. But I still see that the creation of illustrations now will be mainly from reusing CAD data, and I would say that's mainly 3D CAD data. Legacy illustrations, either electronic or scanned from hard copy, then we'd have a hybrid file. So they're really obviously going to remain, I would say, 2D. I don't see any possibility to go into 3D, although we discussed that. The delivery of the file formats really depends what industry you're in, but aerospace and defense and automotive will primarily be CGM. That's the accepted delivery format. So let's discuss 2D and 3D graphics. So we thought we'd make it a bit more interactive, this particular presentation. So we're going to just run a few polls. So this will be the first one. I'm going to launch it now. Just to give you some comfort, nothing is recorded of your name or against whatever you choose or anything like that, so don't be concerned. So I'm going to launch that now. It's completely anonymous. So we'll just let that run for a minute or so. You don't have to vote if you don't want to. Okay. Okay, I'm going to close it. If you want to do a last minute one, then please do. Okay, I'm closing now. And I'm going to share it. So you should see the results. So with pretty much how I would expect it to be, 42% 2D, 30%, 32% 2D and 3D, which kind of surprises me. 8% 3D, which would have been what I would have said, and then 17% looking for 3D in the future. So interesting poll. I think it's pretty much what I thought. I thought that percentage of 2D would be higher, 2D only. Okay, so let's move on from that. So thank you for participating. We have two more, so hopefully don't break up the webinar too much, but I think it's interesting for you as the audience as well to see what other people are doing. So 2D or 3D, that is the question. I think with the overriding driver for technical publications, not just illustration, is always cost. So I think in the near term, 2D will continue to dominate, and is still probably the most cost-effective way and proven way to deliver illustrations. And I think 2D also has that support of trusted open data formats, CGM, SVG, PDF, obviously for some proprietary ones as well. I think 3D though is much more convoluted in respect to formats, because there's so many of them available. Which one do you use? And there's a lot of proprietary ones as well. So it's really a difficult topic. So we've been kind of doing some research into this, and we're kind of mainly basing our research around S1000E and what that specification might require of a 3D format. And what we primarily came up with is it probably will need to be XML. So one of the contenders we've looked at is X3D, and we'll look at that in a bit more detail as we progress through the presentation. So I want to kind of caveat this at the beginning. This is kind of my view, like a world view, like an XML world for text and graphics. So text is already there. The move from SGML to XML was many years ago. So my thinking now is perhaps could graphics go in the same way? Could it standardize on XML? But there would be work required, like 2D, SVG, 3D, X3D. Both of them are XML, so possibly we could move in that direction. And I think there's a powerful reasons for this, for like data management and delivery. Because the benefits would be if it's XML that we could have it's got a structure to it as with the text, so we have consistency. We could validate the data against the schema, and the appearance could be changed based on a style sheet. So all those things are quite powerful for graphics as well as text. So today, we're still really in that 2D creation and delivery paradigm, apart from some exceptions. And there is this huge archive of 2D illustrations. So it's unlikely they're going to go away, and it's unlikely they're going to be converted to 3D because the cost would be just prohibitive. So, and even when 3D CAD data became more easily accessible, it was still converted to 2D. So I think that will continue for some time. The way I see 3D graphics at the moment being used in mainly in technical publications is mainly spare parts catalogs, because I think it's just an easier way to generate them, or they're easier to generate. That doesn't mean that it will go completely that direction, and there's a definite benefit. We can see from using that the delivery and display of the data. But it can also be problematic because you've got to have the right devices to display it on, the right plugins if they're required. And also, there is no real kind of 3D file format for S1000E and ATA. So there's some guidelines about how you deliver 3D files, but there is no real format. So how do you deliver those to the customer if that's a requirement? It'll have to be a specific business rule. So I think aerospace and defense, CGEM will continue to dominate, but we do see SVG being used mainly as a display format at the moment. And again, we'll probably talk about that as we go along more. So what does the future look like? Is it going to continue to be predominantly 2D or a combination of 2D and 3D? So with 3D, there are benefits, dependencies. There's also pitfalls, and what's the cost to deliver the data. So the benefits, I think it's really visually easier to identify parts. You can move to any angle to do that. We could animate parts in 3D, ideal for that kind of removal procedures, repair, maintenance. Much easier for the user to kind of familiarize himself with that task. Or easily reuse CAD data and update the model as it changes. So perhaps we can get data out there quicker to the end user in that way as well. But there are some dependencies. Does the data exist, and what kind of form is it in? Is it accessible? And is there software available to repurpose the CAD data? Because I don't believe the data coming straight out of CAD will serve that purpose. So it would have to be repurposed in some way. So the pitfalls of 3D, will it display on the target device? Does the customer still have to deliver hard copy information? So, because they do, that's going to be a major issue in delivering 3D information. You might have to actually double up and create 2D and 3D. What's the cost to author and the time to author that data? And do we have the correct software, and is it cost effective? 2D. Do we continue down the path of creating and delivering 2D data? I think in the short term, I think still the majority of illustrations will be 2D. However, I think there will be more originated from 3D data and delivered in 3D in the future as well. So I said earlier, I think it's unlikely that 2D legacy illustrations will be updated to 3D. I think it's just the sheer volume, and that the cost to convert and validate that data would be huge. I think also the current mechanism will have to be taken in, delivery mechanism will have to be taken into account. As I said, is it going to be electronic? If it's purely electronic, then fine, but manuals are still delivered in hard copy as well. And I think there'll need to be really a compelling business case for a 3D conversion of this amount to take place. So I think the probable future is a combination of the two, with 3D becoming more common. So the formats, 2D and 3D, I think this is a really important topic, because creating the illustrations is just half the battle. You have to deliver them, and you have to do data exchange and so forth. And this is a crucial part of the publications process. So I think we're all aware of CGM, certainly if you're in the standards-based industry, that is written into the specifications. SVG, I would say it's the new kid on the block, but it isn't really. It's been around a while. But one of its main attractions is that it's native to HTML5, so no plugin is required to deliver the data. And we'll discuss that a bit more here, where we look at the commonality between CGM and SVG. So they're both open formats, and they're obviously not proprietary, so nobody owns them. They're both, I would say, suitable for the creation and maintenance of illustrations. They're the only open graphical formats that I'm aware of that can be hybrid in the respect that they contain editable vector and raster data. And I think editable is the key word. They have the potential also to be validated. CGM already has a defined profile adopted by the ATA and S1000D communities. Metadata can be contained in both file formats, which is crucial. So hotspot information for interactive graphics. And SVG has also that additional ability for animation. And it also can be data driven as well, which is really interesting. So if we're going to display vector graphics in a web environment, then as I've mentioned earlier, SVG is got that native support of HTML5, so no plugin is required. But it's worth knowing that we also created a CGM technology as well, VisX View HTML5, where you wouldn't require a plugin either to display CGM files. So you could actually go either way. You could go to SVG, or you could still use CGM and no plugin for the web browser is required. So what we spoke about earlier was my kind of worldview about XML. And I think this is, to me, an interesting part of SVG, that it is XML encoded. I think there could be some downsides to that. But the upsides are it's based on international open standard, it's structured, it's kind of familiar to the communities, and it could be validated against the schema. So we could easily validate it as we do the profile, the CGM profile at the moment. The caveat is that the schema at the moment is off the shelf, so it really covers the whole spec, so it doesn't define certain elements, which I think we would need in our industry. So a new schema will probably be required. And there's really no rules for the creation of the file at all. So in our experience, interoperability of SVG is really very poor at the moment. But we've tried to address that, and we'll talk about that later. So where is SVG being used? Well, this slide probably 12 months ago, and I would have said that very few aerospace and defense automotive companies were using it, but now that's kind of switched around over the past year, and SVG is really being used a lot, but mainly for the display of the graphics in a web environment, which it was designed to do. It's also used in the GIS community for maps on the web, although Google doesn't use it. It uses still images, it uses kind of raster images to display the maps. One of the big GIS vendors is a company called Esri, if you're interested in that. We found a few graphic arts on the web that use SVG, but I still find it's mainly raster images like JPEG or PNG, or really not vector. That could change though. So I've got some examples here, because I think this is, to me, the kind of the area that we could be exploited, and that's where we have data-driven graphics, and this is SVG. So I'm just hoping this appears. I'm not trying it on here, so let's give it a go. Okay, so this is an SVG graphic, but there's an Excel spreadsheet behind it. So when I move over the graphic, we get feedback in the top left, and you can see that it's changing. So the graphic is actually being driven by data. So this is not probably a great illustration example, but begins to show perhaps the potential of what you could do. And I have another example here as well. You'll get these presentations, so if you want to try these out, and I'm looking for a specific one here, which I can never see. There we go. This is a bit more kind of illustration based. So this is an animation of just interconnecting gear wheels. So you can see that, and again, SVG, and we can see the actual code behind it here as well. So I'm actually you can actually change the number of teeth, so you can see probably the advantages of the encoding here as well. So let me just say if we've got speed. So I'm going to increase the speed of this, hopefully. Oh, I'm probably doing the wrong one, that's why. Okay, we'll run that, and hopefully you see some increase in speed when I scroll back up, and I think we do. So just to give you some examples of what could be possible, say using SVG, a 2D format. So the future 2D, I think in the specifications driven environment, CGM will continue to be the primary format. However, I think SVG will continue to grow as that display format. And the question I've been asked is, will SVG replace CGM in the specifications? But I can't see that happening unless SVG is supported by a profile. It also require the ability to validate that profile, which would require that schema. And there would also be a requirement to amend the S1000D specification itself to include SVG. So not saying that's not possible, but it would take some time and effort to do that. So is this likely? It could happen because I think the nature of SVG is XML. So I think that's an attractive format, obviously, for the community itself. I don't see it ever replacing CGM, but I could see them working in tandem. There'd be a choice of formats. But I think the first requirement will be the creation of an SVG profile. So we did recognize that, so we decided to create one. And the reason behind that is Tech SVG was something we worked on primarily because we have a lot of conversion products that support SVG. So we needed a kind of a standard way of importing and exporting the file. And the SVG specification is large. It's very big. If you've attended some of our other webinars, you might have seen this before. So there's actually the full spec, and then there's the tiny, which was really aimed at kind of mobile phones. And then we defined what we call the Tech SVG profile, which is a subset of the two profiles. So it's only really a restricted amount of attributes we need really for illustrations. So that means now we have a standard way of actually importing and exporting files, which means that they'll become more interoperable in the future. We're also socializing what we've done as well with the communities like S1000D, the aerospace and defense communities, and also we're going to develop more products based around Tech SVG in the future. It's been really useful for us internally as well as a way of standardizing our own products. So as I said, we now have the profile. We could create a schema which would allow us to validate the SVGs against that profile. We haven't done that as yet, but it's something we're working on. And this would provide a really standard way of round-tripping SVG files. So what else could we do? There's also the potential to create style sheets. So perhaps style sheets applicable to the device being used, so the illustration might actually reorientate itself or behave in a different way depending on the device it's being used on. And also we showed earlier data-driven graphics as well. And I've got another good example of that, but this is perhaps a bit more kind of interactive. So this time we have some instrumentation, and you can see, hopefully, top left, I'm actually moving with the cursor the dial, and also here as well if I get in there. So I'm not just clicking on, I'm actually interacting with it as well. I'm sorry these are a bit small. This is a bit more obvious that I drag around, I get a percentage, and then the dial. So you can see that I can interact with the graphic. So this could be really useful for some technical documentation where you want to enter perhaps a value and that actually then feeds back what that value will mean to the end user. So I'm hoping the future for illustration is exciting, and I know you see the same thing. It's not just kind of 2D black and white illustrations. So in conclusion, I think 2D is still going to dominate. As you see, there's a lot of scope what we can do with animation and feedback with 2D graphics as well. And in the near term, new illustrations still will be certainly created or delivered in 2D. But where it makes sense, I think 3D will be used, providing it adds value and the creation is cost effective. So we still need good 2D editing software. We still need to maintain those illustrations, and that's why we're still putting a lot of development into our 2D editing tool, VisXedit. But I see the use of SVG growing, but it will require still some more effort to refine that. Certainly from a data exchange point of view. So before we move on to 3D, I have another quick poll for you to help us out on. Let me, so what CAD systems do you work with? Same as before, I'm going to launch this, and please just vote, and we'll get some feedback to you. I'll just give you some limitations here, that we can only have 5 items in the poll, so that's why we have another, and you probably might disagree with what we put in there, but unfortunately we don't really have we'd like to have more options, but we don't. So anybody who'd like to vote, please do now. If not, then I'll close and I'll share with you. Okay, I think we're there. Okay, let's close, and I'm going to share it with you. Okay, that's a fairly even split, to be honest. So SolidWorks, Dassault will be very pleased to see SolidWorks has got 55%. Obviously, we've got a few. CATIA's mainly using aerospace, so a good portion of aerospace. Inventor's right up there as well, but 64% others. So obviously, there's a lot of CAD systems out there. So obviously, with Lystrom in putting a few more options. Like Unigraphics and so forth, but we thought we'd stick with these 4 and give you the option for other. So thanks for that feedback, that's really useful. I'm going to hide the poll at this point, and we'll get back into the 3D. So I think 3D today, I think the ability to deliver 3D is increasing. I think it really is getting easier to deliver 3D data, and that's really because the hardware is more capable of doing it, even down on the mobile devices. So I think we'll see, it might not be in publications, but certainly in other spheres, 3D. We see on Amazon and things like that, certainly augmented reality and things. I think the software in 3D is just numerous. There's so many different pieces of software out there and so many file formats, as I mentioned at the beginning. And there's a lot of 3D data available for publications, people. So from CATIA, as we mentioned, Creo, and all those different systems that we have out there. But I think there's a big challenge choosing the right file format, and then also then repurposing that data for the end user. In S1000D, it kind of gets a passing mention 3D. So if you've looked at the spec, then there's some guidelines in there, but they are really guidelines. It's only like a couple of pages, if that. And it's pretty kind of common sense. What they're saying is that it has to be verified and authoritative. It should only be used where it kind of serves a purpose. And it still needs to have appropriate warnings and cautions when parts are removed. That will be a challenge for if you're going to repurpose the graphic to add those warnings and cautions into that 3D environment. Might be a bit of a challenge to do that. So the mechanisms for creating and delivering 3D data in telecommunications is really mainly in place. But I think the use can be considered limited, although I think it is growing. And it's inevitable that it will grow as solutions improve and the costs come down. But certainly for the standards-based community, there is no real specified 3D file format, which I think does hold it back a bit. And I think if the S1000D community recommended one, or certainly researched one that would be feasible, then I think that would accelerate, certainly in aerospace and defense, would accelerate the use of 3D. And we really encourage people to use open formats, preferably based on XML. That makes the most sense. So final poll, you'll be pleased to hear. So what file formats do you use in the 3D world? I'm going to launch that now, and again, we only had the 5 options, so we've tried to split that between kind of data exchange and publishing. So perhaps not as meaningful as some of the other ones, but it's still useful for you to see the audience out, what they're using. Probably missed some like IGESs on there, but we could say that step. Okay, couple of seconds, and then I'm going to close, and I'll share with you. So thank you everybody for voting, and I'm going to share that with you. So interesting one. I thought there would be more VMRL, but VMRL is really is an open format, and one of the main formats to see people delivering 3D data in publications at the moment. So that's interesting. Although 3D PDF, that's an interesting number as well. Very interesting. Data exchange, yeah, I would expect STEP to be high, but DWG is higher than I thought it might be. So that's interesting. Gets interesting information for us and where we're going. So thank you again for that today and sharing your information with us. So there are many 3D formats, as I've said already, and a lot of them are proprietary. But what other formats, open formats, are available? Well, I mentioned X3D earlier on, and that's one that we've been researching quite heavily. And we think that's a really nice format and fits well with our strategy. PRC really is around 3D PDF. It's a 3D PDF file. And again, really good delivering 3D images, but you are kind of in the PDF world, which might mean you have to deliver a different type of documentation, say to an IETAN, an interactive electronic technical manual. And then there's U3D, which seems to have been pretty much overtaken by PRC. So why are we focusing on X3D? Well, the main reason is it's open and it's based on XML. The ability to create a specific profile, such as we did with Tech SVG, is there. We could create a schema as well, so we could validate against a specification if there was one. One of the keys as well as with SVG is there's no plugin required in a web browser. So if you want to deliver the data in a web browser, you don't have to put any plugin in there at all. So let's see, I've got some examples here. They're not that easy to work with, but let's bring them up. So the first thing to say is here that we're in, I think we're in Chrome, but we're in a web browser anyway. No plugin, and you can see we can spin this around pretty quickly. I said it's not that easy to work because it was designed really as a concept thing. So we have a whole tree here. I'm going to expand the tree out, and there's a camshaft. So you can see that I can highlight a particular part on this, and I can still move this around. So you can interact with it, but then it goes a bit pear-shaped on me. So let's just go back down. I think it was I clicked something else, but let's go back to the cam if I can find it. I can't see it at the moment. Anyway. But any of these things we could hide as well. So you could see we could hide the main thing. We can then see the pistons inside of here as well. So I think the speed is the impressive thing to me. I know it's not a big model, but the speed is really good. But obviously it's not that easy to interact with this. You can see I'm not really doing anything, but it's kind of highlighting the drive shaft here. So I just want to give you an impression. This is X3D, no plugin in a web browser. So this is one of the attractive things about it. And we can interact with it as well. I think with this one, we can actually do an exploded view, but and you can see we got some text on here as well, but I'm not sure how to get this exploded. And I've got this panel in the way. Let's there we go. So you can see now we've got an exploded view. Again, X3D. So and we've got some text on here as well. Unfortunately, no interactivity, but that's something we're looking at. Again, the speed looks good, and that's some X3D examples for you. So the caveat is, how do we author these files at the moment? Well, that's something we're going to have to think about. Adding interactivity, hotspots, connection to parts list, animations, procedural. So all these things we'd have to achieve and kind of author into this format. So there's a lot to think about, but there will be work required, both from an authoring point of view, but obviously from the standards to get a compliant solution. So finally, technology today and in the future. Well, today we've got probably some users out there who use our 2D VisX edit, and we're going to continue to develop this because of really what we've said already, that there's still a lot of 2D data out there. So we really want it as easy as possible for people to add, say, hotspot information, but also edit files, revise files, add callouts, things like that into the software. And we've completely integrated TechSVG into the product now as well. We're already compliant with CGM with S1000D. And adding those hotspots in today is really easy, and they preserve going through into SVG. So that's an attractive thing. If you want to go from, if you want to just add hotspots to SVG, you can do it through VisX Edit. So one kind of final thing. So this is using, I mentioned VisX View HTML5. So this is using our plugin-less technology, VisX View HTML5. So this is CGM, and you can see that I can interact with the parts diagram at the top here. So with VisX View HTML5, you have a complete environment ready-made to have CGM, no plugin, and say interact with a parts list, and that works both ways. So you can see click on bearing and it highlights down here. We have tooltips, so a little toolbox. So everything you would expect from a plugin is now available without one, and that's a CGM file. Or you could use SVG. We've also spoke a lot about conversion of formats, so we're fully covered on 2D batch conversion. So if you're going to go to CGM to SVG, we have CGM to vector, we have VisX transform, which will auto hotspot files. So really got you completely covered on exporting and converting files from one format to another and auto hotspotting those files. So please go to the website if you're interested in those, and you can get evaluations of them, of transform, CGM to vector, and also obviously VisX edit as well. So what we think about new software. The one thing that we feel is really missing from SVG viewing is an environment. So this is one of the things we want to create for our users, to not only have the option to use CGM, but also a nice option for SVG that at the moment you have to kind of invent your own viewing environment. So we want to try and provide, with our expertise and based around Tech SVG, a viewing environment for SVG. And the other thought further down the road is actually not VisX Edit, but kind of an SVG editing software to take advantage of everything we've been talking about this morning, about data-driven, the animation side and so forth, and leveraging that XML. So it's almost like an XML illustration tool, perhaps. But I think that's a bit further down the road. A new 3D product. So the first thing we're working on for VisX Edit is a 3D to 2D conversion. We've already got the beginnings of it, but that will definitely refine. I'm not going to give a date, so that'll be not the right thing to do. So, but we're working on that currently. We also say, even though there's nobody with VRML, we see that there might be scope to do a VRML to X3D conversion, mainly to make it kind of XML compliant. So that's something we're thinking of as well. And also, as we spoke about a viewing toolkit for SVG, we're also thinking about an X3D viewing toolkit. And also perhaps an authoring environment for that as well. And also X3D profile schema, so we can have that interoperability again that's so important in our industry. So to summarize, sorry if I've gone a bit over time, but hopefully you've stayed with me. We're really continuing, I think, down this road of supporting, our community of graphics customers and the end user, really. Not always using our product, but might just be using it without them knowing it through a viewer. I think the conversion and compatibility compliance are things that we obviously focus on. We need to have good conversion tools, we need to be compatible, and we need to comply with the standards. And we're going to keep going down that route. We really do employ lessons learned. So we get a lot of customer feedback in the conversion area especially, and we're constantly working on our tools to maintain them and make sure the customers are happy that their files are working correctly. The roadmap, we're really developing both 2D and 3D. So we have a really exciting strategy for customers and for new customers in the future, hopefully, that they'll see where we're going with this. And obviously we'll be pleased to work with any companies or organizations who are looking to implement 2D and 3D graphic solutions. So hopefully some questions. I'll just open that up and see if we've got any questions. Okay, one of them unfortunately was about the phone line. So sorry, we missed out on that. So one of the questions, I'll try and answer them or bring Don back in if required. But one of the questions we get a lot, and that somebody's asking it here again, is, and I think we tried to answer it, is will SVG kind of replace CGM as the format of choice? So my opinion, I've already expressed, is that I really can't see that happening in the near term, certainly in aerospace and defense, because of the fact that the CGM is written into the spec, into the S1000C spec. So even if you deliver the file in SVG to the end user, you would still probably, if you're not the actual prime contractor, if you're not the prime, then you're still going to require CGM to be delivered to the customer for kind of archive purposes and so forth. So I don't know do you want to add anything to that, Don, or?
Yeah, well, I think you hit on the essence of it, that it's mainly, its strength is as a display format, and editing SVGs can be problematic because of the broad, the standard itself is just a broad, rich language that there's, for instance, hotspots. There is no standard way of doing the hotspot like there is in CGM. So I just think its suitability for purposes, CGM is very good as a exchange language, whereas SVG is good at display. So that's just my thoughts on it.
Okay. Another question, why did we choose, or why are we focusing on X3D? So again, I'll probably answer that first and let you think about it, Don. But as far as I'm concerned, a lot of our industry is based around XML and open formats. So it just makes sense that from a 3D in the 3D world, we would do the same thing. It might be, I'm not saying 3D PDF is a bad choice at all, and PDF is an open format. But I think a lot of the customers that we work with have IETMs. So it would be nice if they could integrate some kind of view into that seamlessly in a web browser. With PDF, it's possible that they might have to embed it in some way or actually go out to the PDF and then come back again. So it might not be as seamless. So that's why we feel that the community or the standards-based community are more likely to embrace an XML format than they are something else. So that's the main reason. Don, do you want to add anything to that?
Well, again, it's X3D is XML, which makes it really, really strong. And the history of the origins of X3D is that it's really a VRML and XML encoding. In other words, to go VRML to X3D is very natural, and then X3D displays in a browser without any plugins because it's relates to this thing called WebGL, which is built into all the browsers. So it's XML. It's going to be very fast. It's legacy data can be converted in legacy VRML files can be converted directly into X3D. So it's just kind of a natural thing, as opposed to something like the contender would be like PRC, which you can embed in PDF. And of course, there's the Acrobat PDF viewer is the strength of PRC and 3D PDF, but we like X3D because it's XML and it relates well to VRML. So that's our thinking on it.
Okay, thank you, Don. If you have any more questions, please email them to us. We'll be pleased to answer them. I'd like to thank obviously Don for helping out there, and also to you for attending today. This will be our final webinar of 2019. So we'll hopefully see you again in 2020 with our webinar agenda, which we're formulating at the moment, probably more on these topics. So thank you for attending today. You'll get the information via email, so a link to the presentation and the slides and so forth. So have a great day, and we'll hopefully speak to you soon. Thank you very much.